Hey, I am Jack Condon. I'm a senior software engineer at Epic Games based out of Melbourne, Australia. We're here to talk about technical pre-productions, fundamentals in Unreal Engine projects. So I want to start by saying this talk has some opinionated ideas. And these ideas, they don't come from my work at Epic. They come from me working as a technical director for many years before joining Epic, right? So within Epic, as many of you know, I don't work on Fortnite. I work with Tech DevRel. And so my role is to support the community. This lets me do really cool stuff, like put together shows like Unreal Fest and talk about things that I really care about. But the reason I'm saying this, the reason I'm putting this out there is because I just want to make it clear that the advice from this talk doesn't come from how Fortnite does things, right? But rather my experience external to Epic. Anyway, let's dive in, because I said that there's probably too much to cover, so we'll just start. So this talk is really about technical pre-production, or in other words, all the things you should know before you scale production. And when I say scale production, I'm talking about moving more resources into a project and dealing with onboarding issues, right? I've tried to lay out all the major points we need to think about when starting a new project, from developing a tech stack to assets and naming conventions. But I can't say this is a holistic talk, unfortunately. You see, every studio ultimately needs to find their own path on a per project basis. But at least it'll get your minds moving. So let's start by talking about the basics of technical pre-production, to get everyone in the right sort of frame of mind about what we're talking about. Pre-production can mean so many things to different studios and different projects. But I wanted to really cover some really basic common elements and provide a bit of advice about what a finished pre-production might look like. The first outcome is a playable level. This shouldn't be confused with your look dev level that helps you find your art direction, nor is it the demo you made to get funding. Let's face it, that thing is probably hanging on by a thread at this point. This also shouldn't be confused with a gameplay slice that helps design teams, that typically comes during development as your gameplay systems come online, although it can definitely evolve into that. Let's explain it by looking at the questions that it's ultimately meant to solve. It should be able to answer questions like, how are we handling modular assets? How are we considering our models and our model kits interact with Lumen? How are we approaching working with VSMs and Nanite? How are we handling foliage, H level transitions? What tools and processes will we set up for gray boxing? How are we setting up our master materials? How big is a door? We also need to hit target performance on devices we intend to ship to. The goal is to test and try to establish baseline and rule sets, such as how many characters can we have on screen? Can we make our art direction work from our look dev phase? Can we actually get it to work on our target platform? Is it a reasonable amount of work to build our assets, or is it going to be too slow for our timeline? What graphics features are we willing to sacrifice to make sure our core features actually are going to ship on each platform? We also need to answer how we're going to organize content. This playable level should act as documentation for onboarding. Everything should have the right naming and folder conventions and act as an example of how the project will grow. As well, we need to think about our code structures. Leading by example is the best form of documentation, in my opinion. Another good question this playable can ask is, how was the experience to actually build this, right? So we've created one biome, and we should know what totally sucked about that process at this point. It looks great, but maybe it was painful. And if our assets are really hard to make because we're doing something fancy, you may need to think, what automation can we bring into that? Was our level design really difficult for some reason? What tools can we build to help with that? The next thing is probably the most important and certainly the most boring. It has many names. A name I personally like to give this document is a what does good look like document. This is not an art Bible or a game design document. It's everything we've learned through creating our playable on our target device that needs to be converted to documentation. So a good what does good look like document could be seen as a rule set for assets and code production. It is what you expect your team to conform to in order to fight the entropy and chaos that inevitably happens during development. And finally, we need a way to actually share our project with the team and make sure everyone has access to tools. This includes things like your source control layout, using a shared DDC, your CI/CD pipelines, how you're handling content review, and even editor tools. A bit of personal advice, a bit of a hot take, if you will. If your team fail to understand your docs, it's not their fault, it's yours. In my opinion, it is the responsibility of the writer of documentation to ensure that people remember and implement best practice. That's because how we access information is equally as important as the information itself. The reality is people learn in different ways, and we need to accommodate that. One strategy I love is using GitHub for live documents. This example is Allah's style guide. I'm sure we're pretty familiar with this one. It's really fantastic for showing what a naming convention should look like. I really like the way it justifies its decisions, provides examples, but what I really love, it's a GitHub page, so it can be forked. So we're working on projects with specific things, we can handle that. This is actually, the fork that you're about to see is an example of a job I worked on, I don't know, 7, 8 years ago or something. But it was 5 UE projects that had related technology that had to be deployed at once. And so there was a lot of weird conventions. And so by forking it, we were able to put a lot of that information for different teams and allow them to collaborate. Another great idea is to keep your code conventions as part of your actual solution. Now, that actually means that they need to compile. But no programmer can say that they couldn't find the docs if they're literally in front of them. So this idea was introduced to me by an amazing talk in Unreal Fest Europe in 2019 by Valentin Galea. I highly suggest checking out this repo that was provided. I think that it's a really amazing idea, and I also really like the way that they've laid out their code conventions. You can find out more about this as well by checking out that talk. It was called Growing a Healthy Ecosystem, UE4 ecosystem. Finally, you may want to consider validation to automatically enforce rule sets. This can be a great way to stop bad naming conventions and bad referencing habits from finding their way onto your source control, where they're going to be harder to handle. These are obviously just some examples, but you need to be creative. Desktop backgrounds, bathroom stall doors, mouse pads. These are all potential canvases to express your ideas. Remember, it's your responsibility. Next, let's talk about developing our tech stack. In other words, how can we leverage technology from Epic Games? For example, are we planning to use the game playability system or an in-house ability system? Are we going to use state tree or are we going to use behavior trees? Are we going to use replication graph or iris? I love this one. Are we going to use experimental feature or a production ready feature? Well, the truth is, of course, there's no easy answer. And this is maybe the most important decision that we're going to make during technical pre-production. Being able to make a solid tech stack for me comes down to 3 major principles. We need to be aware. We need to keep track of developments in the engine and the community ecosystem. A great way to do this is to keep an eye on our product board. Our product team spend a lot of time keeping this up to date, and it's a really great resource. Another fantastic idea is to create an internal Slack or Discord or whatever you're using channel where people can share their thoughts on new technologies and share their experiments. In a team, we all have separate interests. And so by allowing organic exploration, but then prioritizing sharing information, we let everyone in our company help inform our tech stack. And it's a great way to nerd out about stuff we like. Something that I like to do on each release is to go through the entire plugin list and see what's been added. It takes time, and you need to be happy to crack open the source code to work out how far along something is and maybe even how it works. But you will find treasures in here, and you can keep tabs on how things are progressing. The last one is for the leads and the producers in the room, and that is to dedicate budget to R&D. to discovery of the unknown. It's hard to know what we don't know, but unless we can have realistic timelines to discover it, we're destined to fail. Next up, you always need to validate and share. If you want to find out about a feature, reach out to another studio and see if they've got experience with that technology. And also, well done at being at Unreal Fest. This is probably the best place to have that conversation. But don't forget how important it is to share and grow your local meetups too. Building relationships and sharing knowledge is critical, and rising tides lift all ships. Also, make sure you check out as many project postmortems as you can. These are ways to test tech stacks. And most importantly, get rid of your ego. Once you have a tech stack written down, share it. You don't need to share anything confidential to talk about a tech stack normally, but getting outsider opinions is critical to success, and always be ready to be wrong. Finally, not enough just to validate with the community, you need to test. A great way to do this and speed this up is with epic samples. If you're lucky, there is already a sample that fits together your ideas and it works. But maybe you'll find one close enough at least to speed up your R&D. That's not always going to be the case. So make sure you make technical prototypes with your assumptions. Bad code is fine here. Just make sure the systems fit together and they don't explode. Another fun way is to run an internal game jam. Even though it's costly, it will provide the added benefit of your team telling you how it was like to work with these tools. And it's a great way to justify teams hanging out. Also, of course, feel free to ask us on EPS. EPS is the new UDN, if you have access. We don't mind answering high-level questions, and we know how much pain it can save you in development. If you don't have access to EPS, make sure that you're taking advantage of the dev lounge to have those conversations with all those devs. It's the perfect space for it. But just know, even the best resourced and tested tech stack won't save you from all developer friction. Where would the fun be in that? However, I would say, if you do a good job, you will at least know where your development plan pain points are. And if you kind of know where they are, you can plan production around these pain points. Next up, let's talk about asset contention and avoiding issues during parallel development. So let's talk about using Blueprint versus C++. This is always a really popular topic of conversation, and I guess we need to talk about it when we're planning system design. But if you are feeling the collective groan in this room, it's because it has been spoken about to death. And often, I think, from not the correct perspective. For me, this is how the conversation goes. We compare the pros and cons, and eventually we settle on the fact that they're great for different things. There's no arguing that Blueprints is amazing for flow, handling data and references. Likewise, there's no argument that C++ is better to merge and diff. But let's look at this through the lens of collaboration. What we can take advantage of here is that the technical gaps generally represent the disciplinary gaps, okay? I'm going to walk through this with you, but let's look at this. In general, we expect our programmers to know C++ and Blueprint. And in an ideal team, we expect our artists and designers to know a little bit of Blueprint. Now, obviously, some technical designers and technical artists are going to be C++ whiz. I'm just speaking very generally. So why do we need engineers in our project? Well, one reason is we need people who have fundamental software skills that can write and maintain scalable code. But for artists and designers, their core jobs are in their titles. Still, we all know the power of a designer who can prototype their ideas, and Blueprint is really helpful for this. Does it need to be scalable? Nah, it's okay. But it is still a critical part of a development process. Additionally, it's a waste of resources to have programmers fully implement every feature to its last detail. That's why data-driven design in games is so popular. It gives design control. But this comes with a point of friction, because if artists are implementing their own VFX into gameplay, and designers are extending abilities and whatnot, there's always going to be this fear that they're going to get themselves into trouble. The worst case scenario on everyone's mind, obviously, is fragile code that will break the build. And because of this, programmers typically like tight control. There is a reason they tend to hate those gigantic CSV documents that designers love. I'm seeing some smiles, some admissions of guilt. But here's the thing, the gap between C++ and Blueprint can be the perfect space for this control. So in addition to thinking about C++ and Blueprints are good at, we also need to be thinking about how and what you expose to your systems. Remember, the goal is to create flexible development environments for everyone on the team while ensuring that you don't create fragile systems. Controlling what is and is not exposed to Blueprint is a great way to do this. Ultimately, what I'm saying is really think about your macros. These are going to be your best tool for controlling that. Now, I want to talk about creating a base class in C++ first. Look, a lot of people are already doing this. I still meet teams that are not subscribing to this convention. Now, when I say every class, I'm talking about your game's core classes, not every single class. There are a lot of reasons to do this, and I'm just going to burn through them. I'm not going to do all of them. These are the main ones. One standout is that obviously C++ is easier to diff and merge than Blueprints. And core properties and functions may get a lot of contention are going to be much safer here. Additionally, it's much easier to handle large refactors with typical good coding practices and conventions in C++ rather than Blueprint. Now, Blueprint has had some great improvements here over the years, but I still think this is relevant advice. Also, there are times when you cannot avoid C++, and having a base class available to add functions into will make things easier. But now that function needs to grab a global variable that we've declared in Blueprint, and so we need to move that over as well, right? And of course, you could make a Blueprint function library to handle this, but architecturally, that is a bit dirty for most things. Likewise, you could just reparent your class, right? And that is possible. But having these things laid out creates a smaller barrier and encourages better code practice. And the problem only gets worse when functions need to access other classes that were declared in Blueprint. And all of a sudden, you have a spiraling problem. But you want to make your game in Blueprint only, and perhaps you don't have a dedicated programmer on the team. I get it. To that, I would still say consider doing your headers in C++. That means your core properties, your delegates, your getters, your setters were appropriate. And if I'm asking too much here, please just consider your Blueprint enums and structs. You will still get a heap of advantages when it comes to refactoring and stability. Everyone in this room who knows what I'm talking about, don't mind that I'm wasting their time because they want you to do this, right? And if you don't do it for all of us and me, then do it for Bushranger. That's right, I am not above emotional blackmail. The fact is, this process has become significantly easier and accessible for teams, even if C++ is not a strong suit. This is due to a Blueprint header tool that can generate all the needed header files based on Blueprint classes. So here we have a Blueprint class, and here we can see the generated C++ header. And you can see it even creates our variables and our components. And it even copies all of our meta attributes to the Blueprint as well, which is really cool. And in more complex scenarios, for example, replication, it tells us the changes we need to make in order to have them work the same way. With all that at your fingertips, I think you can adapt to this, and so does Bushranger. Let's talk about asset contention and system design. This is something that gets talked about a lot, so I want to spend a little bit of time with it. But let's define the problem we're looking at as a simple ability, firing a weapon. Of course, nothing in game dev is simple. Design needs to handle damage and effects. Sound needs to handle effects like near misses, hits, fire sounds, and more. VFX needs to handle weapon fires, hits, decals. Animation needs to handle hit reacts, gun animations, a lot more. This thing touches most of our team, right? It's a problem for contention. And most of the team, we expect to be working with blueprints. However, blueprints are going to be much harder to diff And let's not even talk about merging. So we need to think about this in our system design. Let's look at how Gas handles this. Specifically, I'm going to be looking at the Lyra project. This is just a fraction of the system. We're not going to be looking at Anim Notify systems and a few others, but I think it's enough to make my overall point. And I also think it provides some concrete examples of the concepts we've already covered in this talk. So it starts with a C++ base class. Once again, this is the perfect layer to define the core features of this ability. It's handling some scary replication stuff that we don't want our designer team to care about or even understand. It doesn't matter. So having this logic here is a great way to encapsulate it. Now this gets put into a blueprint child. Here we're handling the overall flow and control of the ability, right? Things like triggering the animations. So both technical design and programming are likely to be working in here. That scary replication code is kicked off from the blueprint here. And this will start all that complicated client-to-server networking for the bullet. But, once again, that's encapsulated in C++. Designers don't need to worry, they just call this friendly function. And now is a great time to add some default data as well. From here, we can continue to subclass for each type of line traceability. In this case, we'll look at a rifle. This data-only blueprint, meaning no programming in it at all, is a very good way to handle this. And so, because it's data-only, this is going to be the workspace of design and art. And the nice thing about working with data-only blueprints is that they diff in the editor really well. So they're a much better tool for collaboration. Another great tip when working with them is you've got selection modes that allow us to look at different views of the data. For instance, we can use this only modified view that shows exactly what makes our rifle a rifle. Next up is blueprint for handling damage. In Gas, this is called a gameplay effect. And they're used for all sorts of things, but in this case, it's to apply damage to anything hit. This layer very firmly sits with the design team. Designers can import their own CSV curves into this, or change it to damage over time, or add more complex effects. In this case, it's just applying a static damage value of 12. Gas also uses something called gameplay cues that can be indirectly fired based on ability tags. Basically, they respond to gameplay actions, but they're only there for aesthetic. Like creating a fire particle if a player just caught fire. In this case, we have a gameplay cue that triggers when the weapon's fired. And because it's only aesthetic, this is typically for handling VFX, sound effects, and general feedback. Our sound and art teams are going to live in here. And in this case, our gameplay cue spawns 2 specific actors for different jobs. One handles weapon fire, muzzle flash, and shells. And one handles decals and weapon impacts. And we have other gameplay cues for other specific things, such as characters taking damage. But you can imagine we would have cues for anything we really need. So art and sound can really live in their own environment in that space. Of course, there is more. But I think you can see how all this works to create a diverse, divided system that solves issues with contention. This is not just for encapsulation, but helps with contention. And that's all great, but always, keep memory in mind when you build out these systems, and always think about your use case, is the disclaimer. So let's shift gears and talk about collaboration between UI front-end and back-end. So our design team has passed us some UI wireframes. Now we know where the buttons go. We have a vague idea of kind of where they're going to be placed and the relationship they have to each other, right? Thank you, design. We now need to turn them to beautiful and functional user interfaces. So our UI team will start and get to work and make some really awesome graphics, cool. Meanwhile, our UI is always tied into our game state and a bunch of variables coming from our gameplay team, right? Things like health, shields, attack stance. So all we need to do is combine these elements and we should have a functional user interface. But quite often this creates a problem, as both teams are working in parallel to each other. And when it comes to integration, the worst case scenario is that UI is pulling things from all over the code base. And as these game systems change, the entire UI system breaks down. Additionally, the UI team can't see their data working till the gameplay systems are finished. This is not ideal. However, with some forethought and planning, the two groups can agree on what information needs to flow through the two separate systems and how it will flow through. All they need to worry about is how they connect to this agreement, not one another's work. We call this a contract. This style of working with UI has been around for a long time and is often called MVVM, or Model View View Model. It's really about allowing parallel development to take place by decoupling front end and back end. And even though it's a philosophy, Unreal Engine has built tooling around this to make it a really fantastic process. We call it the UMG View Model plugin. This is the basic flow of how it works. When a user interacts with UI through UMG, instead of sending an event or on a function directly on an object, it will instead modify and it will instead communicate with the view model. For example, perhaps we've changed our character's attack stance. And then the view model is going to send this update to the object. So this will tell the character that, hey, we've requested a new attack stance. If there is a change in the object, for example, our attack stance changes, this will be sent back to the view model. And from there, it will be sent to UMG, and then finally our user can see that, hey, we've changed our attack stance. So in this scenario, the view model acts as a contract for the gameplay programming team and the UI team. So the gameplay programmers only need to care about how they connect to the view model to scope in their development. And the UI team only need to care about binding to the view model as well, without worrying about the gameplay programming team ever again. And so we minimize refactoring and we allow parallel development. And with the new preview widget tool, the UI team can actually preview their UI without modifying values in the contract, right? And this is well before the gameplay systems are ready. So what you're looking at here is the same as a live Pi version of the game, but I'm able to change the values in the contract and simulate the UI. So we've learned about the relationship between C++ and Blueprint with a focus on collaboration, system design and asset contention, as well as MVVM. These are just the surface. My goal is just to get you thinking about how we can make contention better in your own projects. Now let's move on and talk about high-level organization of your code base. And that means having solid plans before you start development. You see, the problem, as we know, is that games are complicated. And like any complicated problem, it's all about cutting it up into bits. Our two biggest tools here are, of course, modules and plugins. So why use modules? Modules are the basic building blocks of UE software architecture. They enforce code separation and hide internal parts of code from other systems. Additionally, they're compiled to be separate compilation units, meaning that they only compile if a module is changed, and this will lead to faster iteration. Also, you have tight control over where they're loaded and unloaded at runtime. Additionally, they can be included or excluded from your project based on conditions, such as what platform you're using. So why use plugins and how are they different from modules? Well, plugins encapsulate modules, meaning that we can group together multiple modules into one conceptual system. For example, an inventory system that contains both editor-only loaded modules and for like internal tooling, and sort of the runtime modules that actually handle the inventory. And unlike modules, we can associate U assets with a plugin. This is great because it means we can package Blueprint children of classes inside of our plugin module with the plugin itself. Thus, the asset is only relevant when the modules it's based on are present as well, stopping sort of loading issues that you might have. So if modules are separate blocks of code, then we can look at plugins, summarize them as enforcing separation between systems. And because by nature they're portable, they're also the fantastic building blocks to build your studio's ongoing IP or tools. Additionally, Unreal systems were made, a lot of the subsystems were made to be extended by plugins, so they're ideal for minimizing engine modifications. However, if we do not have a solid module and plugin planning, your dependencies are going to look like this. And the further we go into development, it's going to get much worse. How can we get this right? Well, I just want to quickly go over the anatomy of modules and plugins to better understand the tools that they have to help organize our code. We're going to be looking at the gameplay message router plugin from Lyra. So modules for the plugin are defined in the uplugin file. Here we can see we have tight control over how they're loaded, and additionally it's worth noting that plugins have other plugin dependencies, so we can build systems on top of systems. A lot of folks miss this in UE5, but we actually have a GUI now for a lot of this. For example, we can now set plugin dependencies from the editor, which I think is really cool. So we know plugins can have plugin dependencies. We also know that they hold modules. We know that modules can be loaded and unloaded based on rules. And we also know that plugins can contain U assets. Let's have a closer look at modules. So this is our module build file. It's a C# script that controls many things such as our modules dependencies. Our module dependencies actually don't care about plugin dependencies, although it is still good practice to still add a plugin as a dependency if you depend on a module in that plugin, and the editor will harass you to do this because you really should. When we look at this, you'll see that we have two types of dependencies, public and private. Public means that we're going to be able to access and include public header files inside of the modules. So that's great for extending classes, using structs and enums and so forth. But keep in mind, it will add to the module's compilation time. As a general rule, you only want to include it if you need to. In most cases, it's going to be more efficient to add a dependent module as a private module. This will allow you to still reference the C++ classes, and you can still use forward declarators to reference your types. Now let's have a quick look at the source files for a module. The first thing you'll notice is that there's normally two folders, sometimes. We have a public folder and a private folder, and I have seen confusion here. Let me just say it has nothing to do with access specifiers like public, private, protected. But you might have also been confused because some folders don't have these folders and some of them just say classes. So I just want to quickly break it down. A public folder will allow other modules to reference included classes of this module. That means that they can extend classes that use their structs and enums that are declared here and so forth. But keep in mind, access specifiers still apply. Header files in the private folder will be hidden from other modules, even if they depend on them. However, they will still be accessible by the module itself. And this is great for containing code that we don't want to be accessible outside of other modules, so we can control how our module is used. Sometimes you might see that there is no public and private folder. Typically, this is when we expect a module to not really have dependencies by something like our our game module, right? You might have also seen a classes folder. That's legacy and kind of acts a bit like the public folder as well. So what do all of these access specifiers and dependencies control let us do? By having tight control and letting us make our systems more rigid and less fragile, we're able to organize them. So first we need to think about our plugin dependencies. Then we need to think about what modules we need. And then we need to think about how they're going to be accessed and what classes will be accessible. And the great thing about this is we keep our systems reasonably decoupled. We can port them easily to other projects. But for me, the main benefit here is having a very modular approach to our software architecture that will help us in testing, compiling, and generally keeping sane. But of course, don't overdo it. It can be hard to see the big picture. And so make sure you work out tests and plan this out however you like. I personally find entity relationship diagrams at this level to be useful, but just use whatever makes sense to you. So far, we've only looked at plugins and modules that our game will be dependent on, right? But what about looking the other way? What about modular blocks that depend on our game? There are a lot of reasons to do this. The most obvious would be things like expansions or DLC content. Game features do a really good job of handling this. They're kind of like fancy plugins that have a slightly different use case. The MO is similar to why we use plugins. It's really about enforcing separation. But rather than systems our game would use, it's particularly helpful for features. These features could be things like a map or a game mode, a skin or a character, an ability, item sets of data. And a really useful feature is that they can be turned on and off at runtime. And this makes them ideal for long-running live services games or content locked behind conditions. Another perk is that we can avoid mistakenly exposing content between releases. All we need to do is not cook these packaged features, and they're not going to go into our build, but we can still keep them in our main branch. Really, they're just going to be a fantastic tool for when we want separation in our game module for whatever reason in a plugin style format. To illustrate how they're different from a normal plugin workflow, I just want to offer you this example. With game features, this is often what we do. We're often going to depend on our game module, right, because we're extending it. Of course, this is not necessary if you had fully standalone content, but it's often what we're going to be doing. I'm pointing this out because this is the difference. We're losing that portability that plugins have, right? And that's why it's a feature and not a portable plugin. They come with their own asset called game feature data, and it can do some really powerful stuff when it comes to injecting features into your experience too. Like in this example, we're able to add additional directories to scan for primary assets after the game feature is turned on. And then we can get a list of those, all those primary assets with this function here. So imagine adding a bunch of new weapons or items, and then we're able to scan all that primary data and add it to the shop to propagate them. I also want to go on a quick tangent, point out a nice engine feature. With all these workflows, it tends to create really complicated plugin dependencies. And so a really nice tool for viewing dependency chains is a plugin called the Plugin Reference Viewer. Before I quickly close on talking about high-level code, I wanted to talk about one quick idea. And that's when we're designing all of these systems, we can make some large productivity bonuses by planning out our public headers first. That is, layering out how the systems intend to communicate with one another before we start development. Remember the idea of contracts from MVVM? Conceptually, we can do something similar by defining how these plugins are going to communicate and forming contracts each system can use. This is getting pretty close to interface-driven development. The main goal here is to try to enforce decoupling and modularity. And this is great for things like how we can use mock data for testing and enable parallel development for an entire project team. There are so many approaches when it comes to software development. I'm sure you can name 10 that I've never even heard of, right? But I just wanted to point out this paradigm as an example of, such an approach you should be thinking about. Let's talk about DLC. Is talking about DLC in pre-production for a game that hasn't shipped crazy? I don't think so. And here's the thing. Even if there's the smallest chance that you will need a DLC strategy, you need to at least loosely conceptualize what it means for your data structures, as retrofitting this stuff is not fun, really. This doesn't mean compromise, it just means planning. So I want to today show you a method that works using some of the things we've already learned today. Note DLC, I guess, means like so many things to other different people, different teams. I'm approaching it from the problem of the content management problem, right? Not sales or Steam or whatever. And another challenge I have about actually approaching DLC as a topic, in Unreal Engine, there are so many ways to go about this problem, right? So it's kind of tricky to suggest one pathway over another. But I would suggest checking out Matt Stafford's talk for even more in-depth stuff. So this method will not work with code modules. It will only work for U assets, right? And maybe that's not a big problem for you. For example, if you're shipping bug fixes and changes this can still go into your base game and keep your community happy, right? And really, it's the heavy assets that we want to chunk and allow to separately download in regards to the content management problem. It's not code files. And this strategy can work wonders for that. But if it doesn't work for you and your team, you need to plan. So you guessed it, we're going to use a game feature plugin to do this. And to make things easier, I'm going to make sure I've got enabled by default ticked. This will mean that the plugin will auto-mount if the DLC chunk is present. And just a reminder, we cannot ship modular code using this method. And here is our amazing DLC content I made. You can tell that this is a programmer talk by my amazing level design skills. Thank you, thank you. I have set up a make-believe perforce as well to show a very simple version of how this setup might be in your production. Probably your streams are a lot more complicated. So we have a stream that holds our base release of our game, right? And we have a child stream that has all our DLC content in it. First, we need to package our base game and give it a release number our DLC can reference. So let's go ahead and open our base stream for now, and we're going to package our build. This is nothing too crazy. We're just using build, cook, run. It's got all the usual trimmings. But note, we are specifying a release version. And this will come up a bit later, and it is essential. That's great. We've packaged our game. Hooray. It's outputted a bunch of chunks. So Lyra uses game chunks for different experiences. That's why there's so many. In chunk 0, it's the base game, it's the menu system, it's the base pawn. Or in shooter maps, these are for the control and elimination game modes, are in chunk 1. And we've got shooter arena, which kind of feels like Bomberman. That's in chunk 2. Either way, Lyra uses chunks. It's something else you need to think about. It becomes really important when you're thinking about like Android and other platforms where you might need to like download extra content on the sides, right? Outside the scope of today. So we're ready to package our DLC and move to our DLC branch. We're going to run build, cook, run again, all the normal stuff, but we're specifying the DLC we want to build. In this case, it's going to be our plugin name. This line is optional. It kind of changes how the plugin files, like their relative location and how we're packaging the plugin manifests with the packs. You can read about it. But we also need to include our release version again. And so we run our game. We haven't got my wonderful DLC map. Everyone's very upset. But if we look in the plugins folder in our archive directory, we'll see that we've got a bunch of chunks with our DLC name. This is looking pretty good. And if we move them into the same folder as our Lyra chunks, then we have access to our sexy DLC map and everyone is happy. So hopefully this helps with some methods for high-level organization. And I hope that, that DLC example just gets you thinking about what does that mean for our game. So now you have really modular code and features. Good on you. But with so many plugins containing content comes a new problem. Dealing with referencing across plugins. The truth is, people will make mistakes here. No matter how good your documentation is, there is just too many places that this can go wrong. And unlike code dependencies that will actually just stop you building, it's harder to stop a bad reference across plugins. Or is it? So here I'm trying to add a data asset to a game experience inside of a content plugin from another plugin that we don't have a dependency on. If I did this, it could cause all sorts of problems, because if that plugin wasn't loaded, I'm going to hit a null pointer, right? But Unreal Engine is stopping me. What is going on here? Well, all I've done is I've turned on the asset restrictions plugin, and it is doing the rest of the work for us. You can see here how it works. I turn it on, and it's giving me an error. And it will flag all the places I can reference, and it'll be like, but you can't do that. All you need to do is turn on the checkbox, folks. So please do this ASAP. It's as simple as that. When it comes to work environments, a real gift that you can give as a programmer to your team is the gift of freedom. Very dramatic. And having a data-oriented approach to tooling is a great way to do that. But artists and designers will still worry they're going to break the build. And programmers will still need to track down these issues as they arise, and there are better things to be doing. What is the solution? Let the trust but validate mantra sing through your editor. It's my advice. So here I'm going to add some game feature actions to our DLC example. However, I'm going to leave them empty, and that's going to be a problem. In fact, I'm hard-pressed thinking about a bigger issue I could add to my DLC, right? And I am intentionally giving it bad data, but note in this example, it's stopping me, and it's even got this pop-up saying, hey, you've done something wrong. And that is thanks to the asset validation plugin. And we can see that game feature data overrides is data valid to perform this check. The implementation here is simple. It iterates over all actions, and it checks if the action is valid. So the actions also have overridden this base function. In fact, any U object can override this function. It's worth noting that we can also override this function in Blueprint as well. So Blueprint warriors can guard their data if they don't feel comfortable with C++. My next step comes around making better workspaces and presenting data in the way it shows its intent. We really need to think about how we're displaying data in the editor. Tooltips and categories really are the bare minimum. We can see a few examples of this in our game feature asset we've been poking poking on. And you can see we've got some fancy stuff. For example, we've got this meta attribute that's got get disallowed classes meta tag for our function. We don't want the user to be able to select certain options. We know that they're going to be bad in this case. And here we see that there's a matching functions dedicated to it. UProperty metadata is really powerful, and it can do a lot of heavy lifting for us. In this example, you can see that we have a stack amount for is only visible. So there's like an inventory, right? If an item doesn't need to stack, we shouldn't give it a stack amount if we're using a Boolean. Implementation is really simple. We just use edit condition and edit condition hide. Inline bools are really simple as well. This allows us to put the same stackable bool in line with that stack amount. And this one is just using inline condition toggle on the bool, edit condition on the int32, referencing that bool. My overall point here is to learn specifiers, what specifiers are available to you. I maintain a great EDC article with more tips around data, being empathetic towards data and design on the EDC that you can check out. And it's got links to all sorts of other resources that are useful as well. And finally, to complete this monumental information dump, we need to talk about 2 more points about testing your stuff in the real world and project distribution. But we are out of time. So to that I say, talks can have dependencies too? I know that's really cheeky, I'm sorry. But look, if you want to learn how to set up source control distribution using Unreal GameSync, setting up CI/CD with Horde, writing functional tests, come see my talk right after lunch. It is going to be more techie than this one, as it's kind of diving through the guts of Horde and how to set things up. But I think that this is really critical for studios in our region to really start looking at their DevOps pipelines. And for me, I made this talk because I don't see enough uptake really in these things where it's become incredibly easy, and that's what I want to prove. So with that, I want to say a big thank you for sticking with me. I hope this was really great. Have a fantastic Unreal Fest. I'm so glad you're all here. Thank you very much.